Okay, this is the M1 paper from January 2024. It's question number 6, and this is a kinematics question. We're going to be using the SUVAT equations. At the end, we're going to be doing a speed-time graph. But let's look into it and make a start. So we've got a particle projected vertically upwards with a speed 24. It's already 2.5 meters vertically above B. B's on the ground. Moves freely under gravity until it hits the ground at V meters per second. After hitting the ground, doesn't rebound. Can we find the value of V? Yeah, absolutely we can. Let's make a start to this. So as with always with these questions, I like to draw a diagram. So we're going to have this sort of scenario. If this is the ground here, that we've got this particle is going from A to B. We know that that height there is 2.5 meters. We know that the initial speed here, u, is given by 24 meters per second. And we want to know what the speed is of v at that point there. So, yeah, I'm going to use SUVAT, S, U, V, A, and T. So S is probably the most important one to think about, that I'm taking upwards as being positive here. So if I'm taking upwards as being positive, at point B, S is minus 2.5. It's 2.5 meters below where it started. I'm taking upwards as positive, so U is 24. V, I don't know. That's what I'm going to work out. And obviously acceleration due to gravity is minus 9.8 there. T, I'm not involved in this question. V, when I've got U, S, V, and A, is going to be our equation V squared equals U squared plus 2AS. So it's simply a matter of substituting everything into that now. So if I do that, I'm going to get V squared is equal to 24 squared plus 2 lots of minus 9.8 and minus 2.5 there. So I get V squared works out to be equal to, if you tidy all that up, it works out to be 625, which means that V works out to be 25 meters per second. So when it hits the ground, it's going at a speed of 25 meters per second downwards into the ground. What does it say for part B? Part B says, can we find the time taken for exactly that thing to happen now? So I've just got the same scenario there. Is it part 2 or part B? Part B, if I want the time taken, I'm simply going to use, now that I've got, what have I got there? I've got V, so I'm going to use V equals U plus AT. So I guess you can write it out again. I wouldn't do this in an exam, but as I'm explaining it to you guys. So S was minus 2.5, don't need that. 24, 25, minus 9.8, and T. Now I can simply go into V equals U plus AT. So V equals U plus AT. Technically, V would be minus 25 at this time then, wouldn't it? Because of the fact that I took upwards as being positive. So I'll get minus 25 is equal to 24 minus 9.8 T. So we get that, rearranging that, T works out to be equal to 49 over 9.8, or minus 49 over minus 9.8, but either way, T works out to be equal to 5 seconds there. So that's part A and part B done. What do we got for next part? It says, find the length of, point C is 10 meters vertically above A. Find the find the length of time for which the particle is above C. So hopefully you've done these questions before. I'm going to put on the same diagram here. What they're saying is that they're saying C is this point 10 meters above A. How long is it in that situation? So what I'm going to do is I'm simply going to put that my displacement will be 10 meters there. And then I'll get a quadratic. I'll get the 2 times here, T1 and T2, and the time for which is above C will be T2 minus T1 will be the difference between those 2 times. So you should have done loads of those with the bookwork that you've done previously, I would hope. So part C, do a new set of SUVAT here, so S, U, V, A and T here. The beauty about these questions is the U tends to stay the same all the way through, and the minus 9.8 for the A is the same. But we're now saying we want the situation where S is equal to 10. Not interested in V anymore. Oops, I'm not doing that thing, let's put that back. And T is what I'm interested in. I'm trying to find out what T is going to be. So I've got S, U, A and T. Well, that's the classic S equals UT plus half AT squared. I've done enough of these questions that I actually know what I've got coming up here. When I sub it in, I'm going to get 10 equals. This is going to be a quadratic once I finish tidying this all up. I also know from my previous work what half of 9.8 is to do it so often. So I'm going to get that equation, which is going to tidy up to 4.9t squared minus 24t plus 10 equals 0. Set it equal to 0 there. I can't do that any other way than using the quadratic formula. So t is going to work out to be minus b, so that's 24, plus or minus the square root of b squared minus 4ac is going to be minus 24 squared minus 4 times 4.9 times 10 all over 2a, so all over 9.8. You can do that. You do that, work out what it works out to be. I've done it previously. It works out to be 0.4598 or 4.4381. They're my two values of t. So the time when it's above 10 meters will be the difference between those two. So time above 10 meters, 10 meters equals, subtracting those two, 3.978, we'll call that 4.0 seconds to two significant figures. So that's parts A, parts B, part C. Part D, sketch a speed time graph for the motion of the particle, but it says don't do any more calculations. So what I should have is enough information on what we've done already to work out the speed time graph. So let's just have a look at the diagram again and say what's happening. Well, the first thing to remember is that it's a constant acceleration all the way through, or constant deceleration all the way through. So if it's a constant acceleration, then the gradient when I'm doing the velocity is going to be just a straight line graph for the velocity time graph. The other thing to say is that what we've got is from there up to that point there, we start off with a velocity of 24, and it will decelerate at a constant rate till it goes down to 0. And then after that, because it's a speed time graph, the speed will just start increasing until it gets to 25 meters per second there. Not a velocity time, but a speed time graph. So let's have a look at doing that then. So what have we got? Part D, we have speed down there, time across there, so let's just say that, speed and time. So, as I said, we know that it starts off at 24 meters per second, 24 meters per second, and we know it decelerates at a constant rate till it comes down to a speed of 0, and then what happens is it will accelerate at basically the same gradient, you know what I mean by the same gradient, hopefully, that, sorry, I'm focusing on the other part here, which is, but it must go up to 25 meters per second for that part there, and we know that that would be equal to 5 seconds. That's the only information I can write on there for all of that. If you want to put sort of a dotted line going across there, you can do. I'm not going to bother. But yeah, in order to get the marks here, we'd need to say that that was a straight line, that was a straight line. In effect, that's symmetrical about that point there, and it goes up slightly higher there than it starts off there. And the full distance, full amount of time is 5 seconds. Yeah, I think that's probably enough to be able to get all the marks for that. What was it? Yeah, it's only 2 marks, so I think that would be more than enough detail what I've said there. Right, so another classic standard kinematics question. Hopefully that makes sense to everybody.